This is the long-awaited Mendel and his pea plants. The first thing. I'll give a close-up of each of the images that I drew. Okay, so Mendel is studying pea plants, and he soon starts to look closely at the details of each plant. Now he's asking himself some questions. Why are some pea plants taller than others? Why are these two plants green, but the others are yellow? That pea plant has pink flowers, but the other one has white. What is that? Why don't they have the same? He noticed some other things as well. Peas were wrinkled, while others were round. Some had yellow peas inside, and some had green inside. So now I drew this one has pink flowers, and it's green, and it's also short. And then this one is yellow, no flowers, and it's tall. And this one, those are white flowers, but white doesn't show up, so I use blue. And it's short with blue, and this is tall with pink. And then down here, there's yellow wrinkled peas, and there's green round peas. So, Mendel soon conducted 2 test crosses. The first was with a tall pea plant and a short pea plant. That resulted in the F1 generation. The second test was pollinating a plant from the F1 generation, and that resulted in the F2 generation. Now, when we go more in depth with the F1 generation and the F2 generation, you see, he crossed everything. So, Mendel cross-pollinated or hand-fertilized a purebred tall. Now, it was a purebred tall plant with the, as it's a purebred, it has homozygous alleles, and he cross-pollinated, hand-fertilized it with a purebred short that also has homozygous alleles. So when he crossed those, that resulted in the F1 generation. And the F1 generation, they were all tall. Then, he did another test where he crossed 2 plants from the F1 generation, but he also cross-pollinated them or hand-fertilized. So he took these 2, and they do not have homozygous alleles. They have like the heterozygous alleles. And he crossed these, and that then resulted in the F2 generation. Now, he was surprised that he didn't get the same results. These ones, there's 3/4 of them that are tall, and 1/4 that is short. Now, the reason for why this happened, I'm going to be showing it in a Punnett square. So, he got the results he did because of the dominant and recessive alleles, or traits. So, you look at the parents. They have homozygous alleles on both sides, but when you put it in the Punnett square, they turn out to be hetero. Now, tall is the dominant trait, whereas short is the recessive. So, whenever the dominant is present, it's present in all of these, the recessive will not show up. It will not show up. So, there is a 100% chance that the offspring of these parents will be all tall. And that's exactly what happened right here. They were all tall. All tall. So, when you come over here, you see the F1 generation. These are their alleles. Because when you put it in a Punnett square, that's how it shows up. So, they all have heterozygous alleles. this is the, right here, it's like dominant. The dominant will show up here, dominant here. But then when you put in the Punnett square, dominant will show up here because the dominant is present. That's the only one that's present. There's no recessive even, no recessive allele even in there. Here, the recessive allele is there, but the dominant is present, so it will not show up there, will not show up here. Oh, but we have a change. There's no dominant allele presented here. So the recessive will, in fact, show up. But you see, here, 3/4 of them are, so the dominant is present in, the dominant allele is present in 3/4, and then it's not present, so it's present in 3/4, which means there's a 75% chance that the offspring, or the F2 generation, is going to be tall. And then there's 1/4 that has the recessive only, which means it will show up. So there's a 25% chance that the short, oh my gosh, what am I saying? Okay, there is a 25% chance that the offspring will be short. And that's what happened. You see there's 75% here, and there is 25% here. So that happens, again, because of the dominant and recessive alleles. So whenever the dominant is present, the recessive will never ever show up. So the dominant was present in the parents, would never show up in the F1. However, when you get to the F1, it is not present in 1/4 of them, so it will in fact show up for the next offspring or the F2 generation. Okay, that one's Mendel and the pea plants.